Okay, so now we will see one thing, that how to represent the set. Okay, I'll take one example, then I will tell you the form of representing the set. Suppose we have a set of vowels of English alphabet: A, E, I, O. If you see the elements of that, they will satisfy one common property. Which property is here? They all are the vowels. They are the vowels of English alphabet. Okay. So either we should write the set like this. This is called a writing in the list form, you can say. We are writing the tabular form or listing method, where each element is written here. What? Each element is written with the commas. But if I will say, I can say this set as A is a set of, try to understand, but we will write in a mathematically, but uh, in reading, or we can say that A is a set of vowels. A is a set of vowels of English alphabet. Alphabet. Okay. So, but this is the way of saying, we can say. But if I will say in mathematically, if I will say that A is the set of all x, where x is a vowel, I can write in mathematical, it is said that A is the set of all x. A is the set of all x, where then we can write what is the property of x, where I will write like this: x is the A is a set of all x. This is the sign which is read as such that x is a vowel, or whatever the property is there. You can write the full property. X is a vowel of English alphabet. So you can see this is, I'm writing here in the singular form. So it is a vowel, singular property. So this, what I have written here, A is a set of all x. What we will read now, this A is a set of all x. A is a set of all x, where, yes, such that, not where, we should say such that, because the sign shows such that A is a set of all x, such that, such that x is a vowel. Are you understanding? So that means we can represent the set in two forms. So today we will see the representation of set. So sets can be represented in two forms. So representation of set. So sets are generally represented by sets are generally represented by two ways. One that we have seen, this is the first form of set representation. It is represented by two ways. Number one, that first form I have written this form, where we are listing the elements, or we are writing in the tabular form, we can say, but it is called roster form. This type of writing, when we are writing in Yes, set builder and roster. Yes. So this is called roster form. First one is called roster form, or it is also called tabular form, roster form, or mostly we are using this roster form in questions also. Roster form, or it is called as tabular form, or it is also called as listing method, because we are listing the element. So that's why it is also called what? Listing method. So generally roster form, we are using roster form. And second type, this is the roster form. This is the example of the same set which is written in the roster form. You getting? Roster form. Okay, got it? Second form is this form where we are representing the set by the property which is followed by each element of the set, of that particular set. So that is called set builder form. That is called set builder form. Set builder set builder form, or it is also called as rule method or rule form. Sometimes we are using rule form also, listing method, listing form also. So rule method, the rule method or rule form. So these are the two ways of representing the sets. Okay, and in first form means roster form. How we will define the roster form? The first form, that is roster form. Roster form. All elements of a set are listed in this form. All elements are all elements of a set. All elements of a set are listed. Means written like this, are listed, and the elements are being separated, and the elements, you can see they are separated by commas. Here this is commas. So the elements are being separated by, are being separated by commas. You should know the definitions also, and are enclosed. Third thing. First thing, listed. Second thing, they are listed with the commas in between them. Third thing is, you can see this curly braces. So it, and they are enclosed within only this bracket. For that we cannot use this bracket. This bracket is not allowed for that. Yes, for that we cannot use any other bracket. For that only this bracket is confined. This is the bracket which will represent only set. So within, that is called curly brace. So we used to say bracket. So this is curly bracket. In the curly bracket, it is written inside the curly bracket. Okay. And in the set builder form, in set builder form, second, in set builder form, as you have seen, we have to write the property. So set builder form, all the elements in this form, in this form, all elements, all elements of set, all elements of set possess a single property. All will have a one property that is compulsory. Otherwise, it will not be a set because it is a well-defined collection. So it will be defined. When it is defined, it will possess the same property. So all elements of set possess a single common property. Single common property. Common property. Which is not possessed by any other element outside the set. Common property is denoted by Px, but we will see that whether to use this Px or not. Px just for representing which is, this is also an important thing, that which is not possessed. If you have taken vowels, so outside the vowels, all in English alphabets, they will not follow this property. So it should be like this, which is not possessed by any other element outside it, by any other element outside the set. Okay, by any other element outside the set. As we have seen previously, that here all vowels we have taken, so outside there will be no vowel. So outside alphabet will not possess this property. So that's important thing. So now, and in such a case, the set is described. How we describe, as I told you, is X such that X is a vowel. So in such a case, it is noted by Px. The set is described. Here we are denoting by Px, but whatever property will be there, we will write that property. For understanding Px, we have taken is described by the set X is a set of X such that Px holds. Px holds means we will write here property. So this is the general form that I have written. Here we will write the property, whatever property is possessed by all the elements. Like I have taken, when V, let's take an example of V is a set of all X such that X is a vowel in English alphabet. English alphabet. Okay, this example I have taken. So like this, we can have some more examples. Let the set of all natural numbers less than 1. How we will write the set? Now we are using the mathematical term for showing this property. Sometimes we have to use less than, greater than. Okay. So here, for example, I'll take one example. Set of all natural numbers. If I will ask you to write in the set builder form the set of all natural numbers. Set of all natural numbers less than 10. Less than 10 in set builder form. So we will say that A, we will write A is a set of all X such that X is a natural number. So now we will use the symbols that I told you. Capital N belongs to natural numbers. So we will write X belongs to natural numbers. Means first property that all the elements are natural numbers, all natural numbers. But second property is also here, and x is less than 10, and x is less than 10. This is how to write in the set builder form. If it is written in the roster form, the same set will be written in roster form. If you will write the roster form of this set, this will become all the elements natural numbers less than 10 is 1, 2, 3, 4, 5, 6, 7, 8, and 9. Less than 10 up to 9 will come. So this is the roster form of the same set. Are you understanding? If I will write just suppose we take only set of real numbers. Suppose I'll ask you to write the set of real numbers in terms of set builder form. The set of real numbers means now we are taking all real numbers. There is no restriction. Okay. So in this case, we can say B is a set of all x such that x belongs to real number. That's all. X belongs to R. So this is infinite set. This is finite set. Okay, got it. So what we have to do, we have to, when we are converting any set, given set into set builder form, we have to find out what property they are belonging. Then these two curly brackets we use x, we will take x, y, or z symbol, or any other symbol x, y, z. We can take any other symbol x, y, z also. And then semicolon. This is semicolon, that is such that after that write the properties of the element. Okay, and enclose the bracket. I think you understood. So we have many examples also to convert, but now we are in condition to complete our textbook exercise first. Okay, so we are going to start textbook exercise. Exercise number 1.1 and question number 1. Exercise question number 1. You will find these questions we have done already. Just I think we have taken the same questions also. So this is, you have to just see past these answers because we have done already. The collection of months of a beginning with the letter J. This is a set because it is well defined. Collection of most talented. No, it is not a set. A team of 11 best cricket batsmen of the world. No, because rating is different. The collection of all boys in your class. Yes, it is a set. Collection of all natural numbers less than 100. Yes, it is a set. Collection of novels written by Munshi Premchand. Yes, it is a set. Collection of all even integers. Yes, it is a set. Okay. So this already we have done before also. Okay. So second question. Uh, Two more things are left. One I'll take all. Yes. Collection of questions in this chapter. Collection of questions in this chapter. Yes, it is well defined. It is set. Collection of most dangerous animals in the world. No, it is not a set. So you have to explain because this criteria varies from person to person or from organ, from some survey. This different survey can give you the different result. So whatever reason you can write here for not having the set. If it is a set, no problem. You can say it is a well-defined and confined set. So we can say this is okay. Okay. So next question is right. Next also we have done actually. Next question also, but here also we will see from textbook this question. You can see question number 2 in your screen. Okay. So here we have to write belongs to, does not belongs to. Very simple. 5, just check 5 is there. Yes, this will be here. Belongs to, we will write here belongs to. 8 is not there, so does not belong to. 0 is not there, does not belong to. 4 is there, yes, 4 is there, belongs to. 2 is there, yes, belongs to. 10 is not there, does not belong to. This is question number 2. Okay. Question number 3. Now write the following sets in, yes. The main type of questions here are that will be asked in examination. Convert roster form into tabular, roster form into set builder form, and set builder form into roster form. Write the following sets in roster form. This is set builder form. So this we will take one by one. The first question: A is a set of all x such that x is an integer. X is an integer. They can write x belongs to z also. The same thing. X is an integer and which is greater than -3 and less than 7. You know this. What is the difference between -3, greater than, equal to, and less than equal to? When greater than equal to, this number is included. This is also included. If it is, means you will have -3 also there, -3, -2, -1, up to 7. Both are included here. Huh? If this sign is not there, that number is not included. Okay. So correct. And your answer is correct. -3 less than -3 is -2, -1, 0, 1, 2. This is the row. This is that. This is that. Sorry, roster form. This is roster form. This is set builder form. This is set builder form where we are using, and this is roster form or tabular form. So roster form is 2, 3, 4, 5, 6. 7 will not come. 7 will not come because less than 7 here. Okay. Similarly, second question: B is a set of all x such that x is a natural number. X belongs to n and x is less than 6. So natural numbers less than 6. You know that roster form is very easy here also. Roster form is b is equal to natural numbers starting from 1. But here we have to take less than 6. 1, 2, 3, 4, and 5. Okay, are you understanding? So writing, converting into roster form is easier as compared to. One more thing I forgot to tell you: if two numbers are coming, we will write one time instead. Like okay, after third question that will come. So question number 3 is two-digit number such that the number sum of the digit is 8. Yes, like these questions, x is a two-digit number. X is a two-digit number. X is a two-digit two-digit natural number. Yes, two-digit natural number such that sum of the digits is sum of the digits. Sum of digits is 8. So we have to find the sum of the digits 8. How we will find? We will start from 1, 1, 1, 7. 1 plus 7. We cannot start from 0 because 0 and 7 will not be two-digit number. So first two-digit number we will start from 1, 1, 7. Then make it 2. This will become 6. 2 plus 6, 8. Then 3, 5. Then correct. Ryan, your answer is correct. 4, 4. Then 5, 3. Then 5, 3. Then 6, 2. Then 7 1 and then 8 0 will also come. So this is the roster form. So this is the roster form where we are getting sum as like this. And the fourth one, just I'll write directly the answer. The fourth one, D, x is a prime number which is a divisor of 60. So divisor of 60 prime numbers, divisor of 60 prime numbers, divisor of 60 are, yes. So question number 4, divisor of 60 are 2, 3 and 5. There are other divisors also, but prime divisors are only 2, 3 and 5. If you see the divisors of 60, how will you find the prime divisor? Just divide, you will get always prime factor. You know that these all are always prime factors. 2 30s are 60, then 2 15s are 30, and then this is divisible by 3, 3 5 are 15, so 2, 3 and 5. The prime divisors of 60 are 2, 3 and 5 only. Okay, and fifth one is, yes, that I was telling you, that trigonometry is the set of trigonometry. Let us trigonometry, T R I G O N O M E and M E T R Y, trigonometry. Okay, so two letters will not be taken two times, one time. We will take each letter one time. If it is coming two times, three times, four times, any number of times, but we will take one. For example, this T is coming two times. So in writing the roster form, we will take T one time. Okay, then R, yes, R is also coming two times. So we will take T R. Then I, okay, I is only one time. So we will write I. Then G is only one time also. So G is one time. O is two times. So cut O two times, write one time O. Okay. Then N is one time. Okay. N is one time. M is only one time. M is one time. E is also one time. So E is also written and Y is also written. So this is the, but here they have used the bigger letters. If it is given letters like this, we can use it. It's not a hard and fast rule. So F is also better. So for better, B is coming one time. Okay, E is coming two times. We will take one. T is coming two times. We will take T, and R is coming one time. So this is the way of converting a builder form, head builder form into roster form. Convert the following in the set builder form. First question. So let it be denoted by A. A is the set of numbers 3, 6, 9, and 12. Okay, 3, 6, 9, and 12. Now we have to write the property. Whenever you have given the numbers, first off you have to recognize whether they belongs to which numbers, integers or some other numbers. So this is looking natural numbers, correct? This is natural numbers, and this is also the multiple of 3. This is also the multiple of 3, but it is a natural number. So its set builder form will be written as set builder form. A is a set of all x such that, so x is a natural number but multiple of 3, because 3 ones are 3, 3 twos are 6, 3 3 are 9, 3 4 are 12. But multiple less than 15. Okay, so we can write x belongs to n, first property, and x is a multiple of 3. X belongs to n and x is a multiple of 3, multiple of 3, and also if I will stop here, so multiples of 3 are 12, 15, all infinite multiples of 3 are there, but here they have given only 4 multiples, that means, and it is less than, x is less than 15, all multiples which are less than 15. Okay, so like this you can write. Now second set number 2 is that it is b 2 4 8 16 32, only 1 minute left. So this is the power of 2, 2 raised to power 1, 2 3 4, 2 to the 4, 2, 2 to the 4 to the 8, 8 to the 16, like this. So we can write it that builder form, x is a set, b is a set of all x, such that x is equal to 2 raised to power n, where number 1 2 3 4 5 up to 5, and n belongs to natural numbers, and n is less than equal to 5, and n is less than equal to 5. That's all. To try other questions also, next time I will take other questions also. To try these 3 questions also. That's all for today.